Salam, peace be upon you. We arrive at a quiet, decisive moment. Up to now, we have been building the discipline of Holophase language, not decorating a story about the universe. We started with the smallest possible commitment, a single mark on a circle. Not a ruler, not a grid, not a clock, not a container called space or time. Just a phase, phi, assigned to each event in a minimal support we call X. Then we refused the first temptation. We refused an absolute zero for the circle. We installed the rule that shifting every phase by the same constant changes nothing structural. If a claim depends on where the circle starts, it is not public truth. It is private labeling. Then we met the next temptation, the wrapping problem. A circle lies to naive subtraction. If you try to compute change directly on a wrap dial, you will sometimes get nonsense. So we introduced a necessary scaffold, a local unwrapping, phi tilde, on patches where unwrapping is allowed. We accepted a second freedom. Even this lift is not unique. You can add a whole number of full turns, 2 pi times an integer, and the wrapped phase remains the same. Any real statement must be blind to that choice. Then we met topology. Sometimes a patch has holes, loops, or defects, places where you cannot unwrap smoothly on the whole region. So we declared branch cuts, not as physics, as honest bookkeeping. A cut set B that we remove so the remainder becomes unwrappable. And we installed the rule that true invariance must not depend on where you place the cut, so long as you do not drag it across a defect. If a quantity changes when you slide the cut, it is not structure, it is pencil marks. Then we install the final discipline before the ladder begins, regularity typing. You do not take second derivatives in a region where only first derivatives exist. You do not speak third derivatives where the object is not smooth enough for third derivatives. Smoothness is not a wish, it is a declared license. We mark patches as C0, C1, C2, and so on, meaning continuous only, first derivatives exist, second derivatives exist, and upward. Only after all of that did the language learn its first verb. We defined the first derivative word. A equals D phi tilde. Say it slowly, as if you're touching something fragile and real. A is a name we give to the first differential object. D phi tilde means the derivative of the lifted phase. It is the thing that tells you, locally, how much the unwrapped phase changes when you move a tiny amount in any allowed direction on the patch. And immediately something remarkable happens. A forgets what must be forgotten. If you shift the phase everywhere by a constant, the derivative does not change. If you add a full turn to the lift, the derivative does not change. A survives the two freedoms that made raw phase unpublic. That is why A is our first publicly meaningful change object. Now we come to the next revelation, and it is the one that turns a single verb into a full alphabet. Reality does not speak in one layer of change. It speaks in layers of change upon change upon change. But we, as finite beings, cannot listen forever. We can only listen as deep as we are licensed to listen. This is the birth of finite jets. Before we define them, let's place an image in the mind that will not fade. Imagine you are standing at the shore at dusk. The ocean is in front of you. From far away, it looks like one vast thing, one surface, one body. That is phi, a single assignment, a single mark on the ring at every event. But when you watch, you notice movement. The surface is not still. Swells rise, ripples dance on top of swells, currents pull sideways, foam forms, collapses, reforms. That first recognition, movement instead of stillness, is the first derivative word, A. Now keep watching. You realize the movement itself is not uniform. The swell accelerates as it approaches. The ripple steepens, then softens. The current bends around the rock. The way the movement changes is a deeper layer. That is a second derivative layer. How change changes. Watch longer. You see the pattern of accelerations changing too. The breaking point shifts. The curvature of the wavefront migrates. That is, how the change of change changes. That is a third derivative layer. And you feel the truth. There is no final layer. The ocean has depth beneath depth. If you could see all the way down, you would see turbulence within turbulence, molecular vibrations, thermal fluctuations, structure nested inside structure. The world is bottomless in detail. But you also feel the human truth. You cannot take infinite layers of attention. You cannot have infinite resolution. Even your best instruments, your best mathematics, your best explanations, each has a limit. At some point you stop not because the ocean ends, but because your listening ends. Finite jets are the language of honest stopping. A jet is not a new physical ingredient. It is not a substance. It is a declared packet of local information. This is how deep we are listening here. We name it JN Phi. That is spoken as JN Phi, meaning the N jet of Phi. And we say what it is in plain words. The N jet of Phi, at a point x, is the finite stack of derivatives of the lifted phase, up to order n, taken at that point, on a domain where such derivatives exist. Let me unwrap that sentence so no one is left behind. Order n means how many times you differentiate. Order 1 is the first derivative. Order 2 is the second derivative. Order 3 is the third derivative. Finite stack means we stop at n. We do not pretend to hold the infinite tower in our hands. Derivatives of the lifted phase means we never differentiate the wrapped circle value directly. We differentiate phi tilde, the local unwrapped version, because calculus requires the line, not the circle. On a domain where such derivatives exist means regularity typing rules everything. If the patch is only C1, you can speak first derivatives but not second derivatives. If it is C3, you can speak up to third derivatives. The domain's type is part of the meaning. So a jet is the alphabet at a chosen resolution. If n equals 0, the jet contains only the value of the phase, what the ring pointer says at that point. That is like a single photograph of the scene. If n equals 1, the jet contains the phase value plus the first derivative word a. Now you have a photograph plus the first notion of slope, how the phase is changing as you move. If n equals 2, the jet contains phase, first derivative, and second derivatives. Not just how it changes, but how the change bends. If n equals 3, you add how the bending bends, and so on. This is why we call jets the alphabet. Each order adds new letters. But the letters are not arbitrary symbols. They are the natural, disciplined answers to one repeated question. How does it change? And how does that change change? And how does that change of change change? A child can understand this ladder without knowing calculus. A child already knows the first few rungs in daily life. Position, speed, acceleration. Those are not three unrelated concepts. They are the first three layers of the same question. We usually stop there, because that is as far as our senses demand for ordinary motion. Holophase says, do not stop because of habit. Stop only because of license. If you are allowed to go deeper, go deeper. If you are not allowed, do not pretend. Now we install the gates that keep jets from turning into fantasy. First gate, well-formedness. A claim about local structure must always declare its jet order n. This is not a bureaucratic detail. It is the difference between honesty and fog. If someone says the phase is smooth here, you must ask, smooth to what order? Smooth enough for first derivatives, second, tenth? A single word, smooth, without a declared depth, is like saying cook until done, without time or temperature. It is not a falsifiable instruction. It is a vibe. So a well-formed statement in this language always carries its resolution. We are speaking at depth n equals 1, or depth n equals 3, or depth n equals 10. The jet order is the declared magnification of the microscope. Second gate, invariance. Jets are built from phi tilde, and phi tilde has freedoms. So jets must survive those freedoms. There are two crucial ones to remember. One is the constant phase shift. If you rotate the circle 0, you add a constant to the phase everywhere. That must not change reality. The other is Lifshitz freedom. If phi tilde is a valid unwrapping, then phi tilde plus 2 pi times an integer is also valid. That must not change reality. Now watch what happens. If you add a constant to phi tilde, its derivative does not change. The first derivative a stays the same. The second derivatives stay the same. All higher derivatives stay the same. Only the raw value of phi tilde changes. If you add 2 pi times an integer to phi tilde, again, all derivatives stay the same. It is a constant shift. Derivatives ignore constants. So the derivative letters of jets, a and everything beyond, are automatically invariant under these two freedoms. That is part of their beauty. It is why derivatives can carry public meaning. But invariance has another face: overlaps and redescriptions. We do not describe the whole domain X with one perfect coordinate system. We cover it with patches. Patches overlap. On overlaps, two ways of describing the same region must agree about what is real, even if they use different local coordinates or different lift conventions. So the JET alphabet cannot be a private dialect. It must transform correctly on overlaps. If one patch calls a direction x and another patch calls it y, the components of derivatives will be expressed differently, but they must encode the same underlying structure. This is not optional. It is the difference between language and noise. That deeper overlap grammar is the next step after jets. But even here, we mark the rule. Jet letters must respect allowed redescriptions. If a supposed invariant changes because you change your descriptive accent, it is not invariant. Third gate, domain. Jets are undefined outside their licensed domains. There is no such thing as a second derivative letter where second derivatives do not exist. This gate is merciless, and it is our friend. It prevents the oldest sin in theoretical storytelling, differentiating beyond legitimacy and calling the hallucination physics. In Holophase, the domain is part of every sentence, not as decoration, as meaning. A statement is never true everywhere. It is true on a declared region, a patch P, possibly with a cut set B removed, possibly with defect neighborhoods excised, and typed to a declared smoothness order. If you do not declare where and to what depth you are speaking, you are not speaking this language. Fourth gate, non-encodability. This is the gate that protects the economy of the alphabet. Someone will always say, your letters are not enough. I need a new primitive letter. Or they will say, your finite jets are not enough. I need the infinite jet as a basic token. The language responds with a challenge. Show that your new primitive cannot be written using the existing tokens. Phi, lift phi tilde, first derivative word A, finite jets, excise domains, and topological invariants. If it can be written, it is not new. It is a derived word, and it belongs later as a definition, not now as a primitive. And about infinity specifically, the gate is even sharper. If someone claims infinite order is required as a primitive, the language says infinity is not a token. It may be an external limit concept you approach, but it is not part of the grammar of finite public sentences. Why? Because a public sentence must be usable. It must be checkable inside some declared window of legitimacy. Infinite derivatives as a primitive is like claiming a perfect map that captures every grain of sand on every coastline at once, forever. You can talk about that as an idealization, but you cannot use it as the basic currency of honest description. Finite jets are the language of usable truth. Now, with the gates installed, we can reveal the structure that makes this feel like a tree. Picture a tree drawn in the mind. The trunk is phi, the circle mark on events. Then the trunk meets a doorway, the lift. Whenever we are in a lift valid patch, we temporarily unwrap the circle to the line, and now calculus can speak. From that doorway, the first branch emerges. A equals d phi tilde, the first derivative word. And now the tree does something that is not a choice, but an inevitability of our entire program. Triunity. Triunity does not mean there exist three separate substances called time, space, and motion. We do not start with those. We do not import them as containers. Triunity means the first derivative word can be read in three inseparable echoes once a reading frame becomes available. Temporal cadence, spatial texture, and kinematic transport are not independent letters. They are three faces of one stem. So the first branch, A, casts three inseparable shadows. You can name them omega, kappa, nu. But whether you name them or not, the tri-echo is there. The derivative word carries a threefold readability. And now the tree grows upward. The second derivative layer is the next branch level. It is d of A, which is d of d phi tilde, which is the second derivative of the lifted phase. You can hear it as how the first change changes. The third derivative layer is how the second change changes. The fourth is how the third changes. At each layer, the tri-echo persists, not because we force it, but because every derivative layer is a refinement of the same stem. Whatever cadence, texture, and transport mean at the first level, the higher levels are simply how cadence changes, how texture bends, how transport accelerates, and all the mixed ways these influence each other. This is the tri-echo tower. Every level has a threefold shadow, and the shadows must recombine into one coherent object because they are readouts, not separate primitives. Now we come to the heart of part 9. Finite jets are the letters of this tree at a chosen height. A jet is like stopping your climb at a particular rung and saying, "This is where we have firm footing. Above this, we do not claim knowledge here." This is not defeat. It is the most powerful kind of honesty because it allows stable communication. To feel that, let's use a human analogy. Imagine a doctor diagnosing a patient. At the shallowest level, the doctor records the patient's words. "I feel pain here." That is like phi, raw assignment of a state. At the next level, the doctor measures pulse and temperature, rates of change, immediate dynamics. That is like A, first derivative word. At the next level, the doctor checks whether the fever is rising or falling, how the change is changing. That is a second derivative layer. The doctor can go deeper: blood chemistry, imaging scans, genetic tests. Each is a deeper layer of structure, a higher derivative order of information. In principle, the body has no end of detail. In practice, the doctor stops. The doctor chooses a finite depth because action must be taken on finite knowledge. And the doctor is accountable. Based on these tests, at this resolution, we conclude. That is exactly what finite jets are for physics and for any discipline description. A publicly shareable declaration of depth. Or imagine map making. A satellite map shows the coastline as a smooth curve. That is a low-order description. A closer map shows bays, inlets, cliffs. That is a higher-order description. Walk the shore and you see rocks and pebbles. Higher still. Zoom further and you see the grains of sand. Higher still. There is no final map. There is only the map at the resolution you need and can justify. Finite jets are the resolution dial of the Holophase language. Now we state the principle that makes jets not just a technique, but a philosophical and scientific spine. Reality may be infinitely deep, but any publicly distinguishable local structure should be capturable at some finite jet order. This is the prediction of part 9, said in simple words. If something makes a local difference that we can agree upon publicly, then there exists some finite depth n such that the n-jet captures what makes that difference. You might need n equals 2 for a rolling ball. You might need n equals 4 for a vibrating string. You might need higher n for subtle phenomena. But you do not need infinite n as a primitive letter. Infinity is not a letter in the alphabet. Infinity is the direction the alphabet can grow. And that brings us to the formal falsifier, again in simple words. If someone can show a local, publicly distinguishable structure that cannot be captured at any finite depth, and that requires infinite jet order as a primitive, then the finite jet alphabet would be incomplete. Notice the difference between requires very high n and requires infinite n as a primitive. Those are not the same. A coastline can require more detail as you zoom in, but at any given scale, a finite description suffices. Pi has infinitely many digits, but any engineering calculation uses finitely many. Holophase places the same bet about physical structure. For any public task, at any public scale, a finite depth is enough to speak. Now we must connect jets to the other half of the language, topology. Because the Holophase language is not only about smooth layers, it is also about the places where smooth layers fail in a structured way, where integers appear. When a phase winds around a defect, you cannot define a single smooth lift across the whole region. That is not a problem to be swept away. That is the universe telling you, here is discrete structure. So the complete picture is, jets describe the smooth regions where lift exists and derivatives are licensed. Topology describes the global wrapping facts, winding numbers, holonomy, defect charges, that remain when you move cuts, change lifts, shift phase zeros, or change patch descriptions. Jets are the continuous vocabulary. Topology is the discrete punctuation. To see their partnership, imagine a river flowing around a rock. You cannot describe the water inside the rock. So you excise it. You remove that region from the domain. On the remaining domain, you can describe the flow with smooth derivatives, that is jets. But the presence of the rock produces a global fact. Circulation around it, patterns of vorticity, the way the flow cannot be smoothed into a trivial pattern without acknowledging the obstruction. That is topology. Global invariance determined by loops. Holophase treats defects and excisions similarly. We speak jets on clean domains and speak integers around what has been excised. This is why the language is so powerful. It produces continuity and discreteness from one starting point without importing them as separate substances. Now, to seal the main takeaway, we make the grammar of finite jet sentences explicit in a single line. A local sentence in this language has the form f of j and phi equals 0 on domain D. Say it in words. Take the jet of phi up to order n on a declared domain D where such derivatives are licensed. Feed that finite information into some rule f. The rule holds on that domain. This is not yet dynamics. We are not saying what f is. We are freezing the alphabet and the grammar so that later, when we propose laws, we cannot cheat by smuggling in new primitives. And now you can feel why part 9 matters so much. Without finite jets, the language would be vague. There are infinite layers of change, true but unusable. With finite jets, the language becomes both humble and sharp. There are infinite layers, but at any moment we speak at a declared depth on a declared domain, and our claims must be invariant under allowed redescriptions. This is what makes the language public. This is what makes it scientific. This is what makes it safe. Now let's return to the tree image one last time and climb it in the mind. At the base, phi, a phase on a circle assigned to events. Then the first discipline, no absolute phase. Then the leaf doorway, phi tilde. Local unwrapping were permitted, with the rule that phi tilde plus 2 pi times any integer is equivalent. Then branch cuts when needed. Declare cut set B. Lift lives on P minus B. Invariance must not depend on moving the cut. Then regularity typing. Declare smoothness depth Cn. Then the first derivative word. A equals d phi tilde. Then the finite jet. J n phi. The finite stack of derivatives up to order n. This is the alphabet, and it has a remarkable character. It can grow without end, but it is always usable in finite slices. It is infinite in principle, finite in practice. Infinite depth, finite access. Now we end part 9 with a single sentence that carries the whole structure, without clutter. Finite jets are the honest alphabet of local structure. A declared depth n, built from the derivatives of the lifted phase, valid only on licensed domains, invariant under allowed redescriptions, and complete in the sense that anything locally distinguishable should be capturable at some finite depth. That is what we have achieved, and now there is one natural next step. So natural, it feels inevitable. If jets are letters, then we must learn how letters change their appearance when you change your writing style. The same word looks different in different fonts, but it is the same word. In our language, the same jet data looks different when you change coordinates, change patch descriptions, or move between overlaps. If we cannot translate between these accents, we do not have a language. We have private scribbles. So the next part is not about adding new letters. It is about learning the grammar of translation. How jets transform on overlaps, how the same structure is recognized through different descriptions, and how invariance is enforced across the patchwork of the world. That is where we go next. For now, we carry the tree in the mind. One silent circle letter, one honest unwrapping, one first word of change, and then a finite alphabet at any chosen depth. An alphabet that can always grow, but never lies about how far it has grown. Always. Peace be upon you.